Good morning, everyone. Welcome to today's hearing. Today we're going to continue hearing closing statements from various call participants, and we're going to begin by hearing a statement from Mr. Craig Orr, King's Counsel, on behalf of Celotex. So, Mr. Orr, when you're ready, make your way to the podium and we'll look forward to hearing from you. Thank you.
Mr. Chairman, Ms. Istefan and Mr. Akbor, good morning. Celotex thanks the inquiry for this opportunity to make a closing statement at the conclusion of Phase 2. Celotex welcomes the methodical and rigorous approach that has been taken by the inquiry. That was clearly the right approach to take when examining the causes of a tragedy of such immense scale and seeking to ensure that no such tragedy occurs again. Celotex repeats its deepest sympathy to the bereaved survivors and all those affected by the Grenfell Tower fire. From the outset, Celotex has been committed to providing its full cooperation and assistance to this inquiry, as well as other official investigations arising out of the fire. Immediately after the fire, Celotex commenced its own investigations into the supply of its products that were used in the refurbishment of the tower. Prior to being asked for documents by the inquiry, Celotex arranged for relevant documentation to be identified, secured, and thereafter reviewed by its external advisors. Celotex has been proactive in bringing all relevant information to the attention of the inquiry. It has been candid about issues which its current management have uncovered in the course of their investigations, and it has taken effective steps to ensure that those issues do not reoccur. I will return to the issues uncovered by Celotex's current management later in this statement. It is important that those issues are seen in their proper context in the light of the whole of the evidence which has emerged during Phase 2. In Celotex's submission, that evidence confirms 3 points of fundamental importance. First, that any shortcomings on Celotex's part had no causative impact on the specification and use of Celotex's products at Grenfell Tower. Second, that Celotex insulation could safely be used in a cladding system with a combination of other appropriate materials in accordance with the statutory guidance in force at the time of the refurbishment. Third, that Celotex's insulation played at most a minor role in the external spread of fire at Grenfell Tower. The work carried out by the inquiry's experts has demonstrated that the external fire was driven to an overwhelming extent by Arconic's polyethylene cord Rainabond ACM cladding panels, and not the insulation installed behind those panels. As Professor Bisbee said, Rainabond ACM PE cladding is a uniquely hazardous product that presents extreme fire hazards and should never be used on building facades. Given the presence of that cladding on the tower, the fire would have spread in materially the same way whatever insulation was used. Celotex's position in relation to the issues examined during Phase 2 is set out in detail in its various written submissions. Those include, most recently, Celotex's overarching closing submissions provided to the inquiry on the 30th of September. Celotex's position has been consistent throughout and is strongly supported by the factual and expert evidence heard by the inquiry. In this closing statement, I propose to comment briefly on 5 matters as follows. First, Celotex's role in relation to the refurbishment of Grenfell Tower. Second, the regulatory system. Third, the specification and design of the cladding system at Grenfell Tower and the appraisal of that system by Orr KC Building Control. Fourth, Celotex's product literature. and fifth, the expert evidence as to external fire spread. I turn first to Celotex's role. Celotex's connection with Grenfell Tower was as the manufacturer of two insulation products used in the refurbishment. RS5000, which was used as insulation in the cladding system, and TB4000, which was, Celotex now understands, used to fill gaps in the window surrounds at the tower. Both products were PIR, a combustible form of insulation. Their combustibility was clearly highlighted in Celotex's health and safety data sheet, which was available on Celotex's website and expressly cited in Celotex's product literature, including the RS5000 data sheet on which certain construction professionals involved in the refurbishment claim to have relied. As the manufacturer of a single component used in the cladding system at Grenfell Tower, Celotex was not responsible for the design or compliance of that system. The design and compliance of the system was the responsibility of the specialist designers, contractors, and consultants engaged on the refurbishment, including Studio E as architects, Ryden as the main contractor, Harley as the cladding subcontractor, and Exeter as the fire engineer. Each of those construction professionals had specific responsibility in relation to the design and construction of the cladding facade under the terms of their respective contracts. They were responsible for ensuring that the cladding system complied with the building regulations. Celotex was not part of the design or construction team on the Grenfell Tower project. Celotex is not an architect, designer, building contractor, or fire engineer. It does not design, manufacture, supply, or install cladding systems, and it did not do so at Grenfell Tower. It also does not install insulation, and it did not do that at Grenfell Tower. Celotex's sole role in relation to the refurbishment was as the manufacturer of insulation specified and used by others in the exterior wall construction. Celotex was never asked to verify or provide assurance that the cladding system designed for or installed at Grenfell Tower was compliant, and it did not do so. The market for cladding systems was and is a specialist one. Celotex reasonably took the view that it was for designers, contractors, and specialist consultants to specify, design, and construct the cladding system on any particular project, and to verify compliance of any such system with building regulations. As the manufacturer of a single component of a multi-component system, Celotex could not reasonably have been expected to input into the design of that system or ensure compliance with the system. While Celotex was provided with some information about the proposed cladding system at Grenfell Tower, it was not privy to full details of the design process and had no access to the contractual documents governing the refurbishment or the NBS specification which governed the selection of products. Moreover, Celotex had no dealings with the architect or fire engineer whose input would have been relevant to assessing the cladding system's compliance with building regulations. I turn then to the regulatory system. Now, the evidence heard during Modules 6 and 7 throws important light on the regulatory regime governing the fire safety of high-rise buildings. The following matters are, Celotex submits, clear. First, the building regulations and statutory guidance in force at the time of the refurbishment permitted the use of combustible insulation in a cladding system installed on a building over 18 metres in three situations. One, where the complete cladding system was shown by a full-scale fire test in accordance with BS 8414 to meet specific performance criteria known as the BR 135 criteria. Two, where a desktop study was obtained from a specialist fire engineer confirming that the cladding system would, if tested, meet the BR 135 criteria. And three, where a holistic fire engineering assessment was obtained, which confirmed that the cladding system met the requirements of the building regulations, taking account of the adequacy of the fire prevention measures in the building as a whole. There was, at the time of the refurbishment, a fourth route to compliance known as the linear route, but that only applied where the insulation used in the cladding system was of limited combustibility. That route was not therefore available where combustible insulation like PIR was used. Neither RS5000 nor any other Celotex insulation product was marketed as being a material of limited combustibility or as being capable of meeting the linear route to compliance. Each of the routes to compliance I've mentioned was recognized in Approved Document B, which contained the government's statutory guidance concerning the fire safety of buildings. This includes desktop studies. Approved Document B acknowledged that the performance of materials, products, and structures could be assessed from test evidence by suitably qualified fire safety engineers. Although the use of desktop studies has been criticized, the evidence shows that they were an established route to achieving compliance at the time of the refurbishment. Several of the inquiry's experts confirmed that desktop studies had become common by that time, including Mr. Hyatt, the architectural expert, Mr. Sackler, the cladding expert, Ms. Menzies, the building control expert, and Dr. Lane, the fire engineering expert. That is unsurprising given the unfeasibility of carrying out a full-scale BS 8414 test of every possible combination of components in a cladding system. Whatever criticism might be levelled against the fire engineering analyses underlying particular desktop studies, that is a matter for the fire engineers concerned and not the manufacturer of an individual component of a multi-component cladding system assessed by way of such a study. Manufacturers were entitled to operate within the parameters of accepted industry practice and to rely on fire engineers to carry out desktop assessments in accordance with appropriate fire engineering principles. It's also important to note that it was clear from the building regulations that whatever route to compliance was followed, the external walls of a building must adequately resist the spread of fire over the walls. That was an overarching requirement that governed the fire safety of every external wall construction. The regulatory principles I have outlined were or should have been known to any competent construction professional at the time of the refurbishment. However, a number of construction professionals involved in the refurbishment have sought to rely on alleged flaws in the drafting of Approved Document B to excuse their failure to have proper regard to the applicable principles when designing and constructing the cladding system at Grenfell Tower. These construction professionals have in particular sought to rely on alleged confusion between the concepts of limited combustibility and Class 0 to justify their design and construction of a non-compliant cladding system at Grenfell Tower. They suggest that this alleged confusion excuses their misapplication of the linear route to compliance. Celotex invites the inquiry to reject these submissions. So far as the use of insulation is concerned, the guidance in Approved Document B was clear. In a building above 18 metres, insulation could only be used in accordance with the linear route if it was of limited combustibility, which was a defined term. The definition made clear that limited combustibility was a separate concept and was distinct from Class 0, which was separately defined. A clear distinction was drawn in Approved Document B between these two concepts. They were not interchangeable. If following the linear route, Class 0 was not a relevant criterion for use of insulation. Under the linear route, Class 0 applied only to the external surface of a wall. In the case of a cladding system, that meant the external surface of the cladding panel and not the insulation behind the cladding panel. As Celotex explains in its written submissions, Class 0 was a relevant performance criterion for insulation in other contexts. However, under the linear route, as I've said, Class 0 applied only to the external surfaces and not the insulation. Any competent construction professional should have known this. Insofar as there may have been confusion within the industry about the distinction between Class 0 and limited combustibility, that was or should have been clarified by guidance that was in wide circulation at the time of the refurbishment. In particular, a guidance note issued by the Building Control Alliance warned that rigid foam insulants such as PIR did not meet the limited combustibility requirements of approved document B and should not be accepted as satisfying the linear route to compliance. Similar warnings were given in other guidance available at the time. It therefore was or should have been clear to any construction professional involved in the refurbishment that combustible insulation such as RS 5000 could only be used in the cladding system if that system was shown by testing or assessment to meet the BR 135 criteria or a holistic fire engineering study was undertaken of the building as a whole. Now, it's fair to say that there was more room for debate about the guidance in approved document B concerning the use of cladding panels in a building above 18 metres. The evidence heard in Modules 6 and 7 highlighted the potential ambiguity about whether and how specific provisions of approved document B applied to the core of a composite cladding panel. This included ambiguity about whether the core of a composite cladding panel comprised filler material and was therefore required to be of limited combustibility if the building designer was following the linear route. While central government is responsible for failing to address this potential ambiguity before the Grenfell Tower fire, as the Department for Levelling Up has accepted, Celotex agrees with the department that a competent professional applying their mind to any confusion caused by the word filler, and considering whether to use an ACM panel with a combustible core, should have concluded that such a panel could not meet the functional requirements of the building regulations. This was or should have been clear to any competent construction professional from warnings given in approved document B and other industry guidance about the hazards of using combustible materials in a cladding system. Indeed, the Building Control Alliance guidance, to which I have referred, advised in clear terms that if following the linear route, materials of limited combustibility should be used for all elements of the cladding system, including the cladding panels. The same guidance expressly noted that a surface spread of flame classification, such as Class 0, did not infer any resistance to combustibility. A composite cladding panel with a Class 0 classification could not therefore be assumed to be safe if it contained a polyethylene core. Had a construction professional applied their mind to the available guidance and the functional requirements of the building regulations, they should have concluded that the polyethylene core Rainabond ACM cladding panels proposed for use at Grenfell Tower could not safely be used in compliance with building regulations. It follows, as Professor Bisbee said, that any perceived ambiguity in the wording of approved document B cannot credibly be used to absolve design or construction professionals of their responsibility for failings as regards installation of unacceptably dangerous external cladding on buildings. There is furthermore no interpretation of approved document B which permitted combustible insulation such as PIR to be used in a cladding system on a high-rise building without further testing or assessment. I turn then to design and construction of the cladding system at Grenfell Tower. Had the construction and building control professionals involved in the refurbishment paid proper regard to the regulatory requirements I have outlined, it would have been clear to them that the cladding system designed for Grenfell Tower was not compliant and should be redesigned. Instead, the relevant professionals paid scant or no regard to the functional requirements of the building regulations or the applicable guidance. Their knowledge and understanding of the building regulations and of approved document B was shown in evidence to be very poor or non-existent. Among other things, the construction professionals gave no proper consideration to which, if any, potential route to compliance they were following. They had no regard to the fact that the insulation and cladding panels were combustible. They did not consider what impact that combustibility would have on compliance of the cladding system with the functional requirements of the building regulations. They failed to appreciate that the linear route to compliance was unavailable because of the Celotex insulation they had selected. They failed to recognize that the polyethylene cord ACM cladding panels they had chosen were so highly combustible that the panels could not meet the requirement of the building regulations that the external walls of a building must adequately resist the spread of fire over the walls. And finally, they undertook no assessment of the fire performance of the cladding system as a whole, whether by way of a BS 8414 test, desktop study, or otherwise. These matters were not Celotex's responsibility. They represent fundamental failings on the part of the construction and building control professionals who were responsible for the design, construction, and appraisal of the cladding facade at Grenfell Tower. This includes in particular Studio E, Ryden, Harley, Exeter, and RBKC Building Control. The evidence heard by this inquiry demonstrates beyond doubt that those professionals lacked the necessary skills, knowledge, and competence to carry out their respective functions. Celotex has identified in its written submissions the many serious failings by the construction and building control professionals involved in the refurbishment. The same failings are identified in submissions made by other core participants, including BSR Teams 1 and 2. Importantly, the failings identified by Celotex are all supported by the expert evidence of the inquiry's own experts, who have been trenchant in their criticism of the incompetence displayed by the professionals responsible for the design, construction, and appraisal of the cladding facade at Grenfell Tower. In brief summary, the failings by the construction and building control professionals that are apparent from the evidence include the following. As regards Exeter, they failed to produce an adequate fire safety strategy, despite having agreed as the designated fire engineer to produce a detailed fire safety strategy for the development of the refurbishment, which would ensure a high standard of fire and life safety for the occupants of the building. Exeter failed to undertake any assessment whatsoever of the cladding system, despite knowing that the refurbishment involved overcladding of the tower. To make matters worse, Exeter wrongly stated in draft fire strategy reports, which they never completed, that the proposed changes would have no adverse effect on the building in relation to external fire spread. Mr. Ashton, the fire engineer who authored these draft reports, admitted in evidence that he knew that polyethylene was highly combustible and that polyethylene cord cladding panels could exacerbate the spread of fire over external walls. As regards Studio E, the architects, they specified combustible insulation for use in the cladding system without considering the fire performance of the insulation or the compliance of a cladding system incorporating that insulation. They also selected Rainabond ACM PE cladding panels without any adequate understanding or investigation of the fire performance of those panels, or whether a cladding system incorporating the panels would comply with building regulations. The evidence showed that Studio E lacked any meaningful understanding of the fire safety provisions of the building regulations in approved document B. Studio E never properly applied their minds to which route to compliance was being followed at Grenfell Tower. As regards Harley, the specialist cladding contractor, they proposed the use of RS 5000 in the cladding system at Grenfell Tower without undertaking any investigation of the product's fire performance. Harley also strongly pushed for the use of ACM PE cladding panels, despite the hazards posed by such panels. As noted by BSR Team 1, Harley appears to have been actually aware of those hazards at the time. Harley's design manager, Mr. Akentel Jones, admitted in an email exchange with other members of the design team during the refurbishment that the Rainabond ACM PE cladding panels would be gone rather quickly in a fire. Mr. Anketel-Jones told the inquiry when giving evidence that this was a fact known throughout the industry. This evidence cannot be explained away, as Harley now submits. Furthermore, the inquiry's cladding expert, Mr. Sackler, confirmed that any cladding contractor should have known of the dangers posed by ACMPE cladding panels by the time of the refurbishment, and should have concluded that the use of such panels at Grenfell Tower would be unsafe and would not comply with building regulations. Harley's criticisms of Mr. Sackler's evidence are, Celotex suggests, misplaced. Harley's contention advanced yesterday that it was not responsible for the fire safety of the cladding facade and not required even to consider the building regulations is, Celotex submits, plainly incorrect. Mr. Ray Bailey accepted in evidence that Harley had an obligation to comply with the building regulations that must include the functional requirements and the fire safety provisions in approved document B. I turn to Ryden. Despite being the main contractor with overall responsibility for design and construction of the refurbishment, Ryden gave no thought to the fire performance or compliance of either the insulation or the cladding panels used at Grenfell Tower. Ryden nevertheless intervened in value engineering discussions in mid-2014 to advocate strongly for the use of ACMPE cladding panels in the face of reluctance from RBKC's planners. Ryden's motivation in doing so was to secure approval for the cheapest type of cladding so as to enable Ryden to recoup a shortfall in its budget caused by a costing error in its tender. Ryden's failure to check the suitability of the cladding panels that it was proposing should be used was clearly negligent. The evidence shows that Ryden's personnel were so poorly trained and had so little knowledge of design and compliance that they were unable to carry out any effective supervision and oversight of the subcontractors and consultants working on the refurbishment, including Studio E and Harley. Indeed, Ryden's witnesses admitted that their practice was to rely on building control to check compliance because Ryden lacked the knowledge and expertise to do so itself. It was clearly wrong for Ryden to rely on an external regulator to perform what was one of Ryden's own essential responsibilities as the main contractor on the project. Ryden's negligence extended to the wrongful design and construction of the window surrounds on the tower. Ryden was responsible for Celotex TB4000 and other combustible insulation being used to fill gaps in the window surrounds. That was contrary to the contractual specification, which required non-combustible insulation to be used in gaps, and was, moreover, not compliant with approved document B. The wrongful use of combustible insulation in the window surrounds was significant. As the inquiry's experts confirmed, it meant that there was a disproportionately high probability of an internal fire near a window spreading into the cladding system, as in fact happened on the night of the fire. The Celotex TB4000 used in the window surrounds was purchased by one of Ryden's subcontractors, ST Plastering, from a builder's merchant. Celotex did not know and had no means of knowing that TB4000 was purchased and used in the refurbishment. Celotex only learned that this product had been used after the fire. The inappropriate use of TB4000 at Grenfell Tower was Ryden's responsibility. As regards RBKC building control, they failed to carry out any adequate investigation, inspection, or assessment of the cladding facade in serious breach of their responsibility as the designated building control body for the refurbishment. The extensive failings by its building control department have been admitted by RBKC, which accepts that the completion certificate issued in July 2016 by RBKC Building Control should never have been issued. The evidence shows that RBKC's Building Control Department was poorly managed, systemically under-resourced, and ill-equipped to carry out its functions. The building control officer allocated to the refurbishment, Mr. Hoban, was unfit for the task. He had no prior experience of high-rise residential buildings. He was inadequately trained and lacked relevant knowledge about the fire safety requirements for cladding systems in buildings above 18 metres. In his expert report, Mr. Hyatt said that the Grenfell Tower refurbishment project had been run and delivered in a chaotic manner, and that the numerous failings by the professionals responsible for the project represented a serious indictment of the services they had provided. There is no doubt that if the relevant professionals had acted competently, the design of the cladding facade would have been overhauled and the unsafe construction and consequent fire would have been prevented. I turn next to Celotex's product literature. Some construction professionals have sought to argue that they were misled by Celotex's product literature into believing that use of RS 5000 in the cladding system at Grenfell Tower was compliant. However, for the reasons set out by Celotex in its written submissions, there is no reliable evidence that anyone from Studio E, Harley, or Ryden read the RS 5000 product literature, let alone relied upon that literature, or was misled by it. Nor is there any reliable evidence that anyone else involved in the refurbishment was misled by the RS 5000 product literature. Celotex respectfully suggests that the construction professionals involved in the refurbishment cannot credibly contend that their design and construction of a non-compliant cladding system can be explained by their reliance on Celotex's product literature. RS 5000 was marketed from August 2014 on the basis that it had been incorporated within a cladding system which had been demonstrated to meet the BR135 criteria by way of a test to BA 8414 Part 2. The RS 5000 product literature clearly stated across multiple documents that the fire performance and classification report issued for the product only related to the components of the system described in the literature, and that any changes to the components listed would need to be considered by the building designer. This accurately reflected the requirement in Approved Document B for any cladding system containing combustible insulation in a building above 18 metres to be shown by test or assessment to meet the BR135 criteria. Celotex produced a rain screen cladding compliance guide which drew specific attention to the requirements imposed by Approved Document B for the exterior walls of a building over 18 metres, the risk of external fire spread in cladding construction, and the importance of building designers ensuring that any cladding system incorporating RS 5000 met the BR135 criteria. The rain screen cladding compliance guide was a key part of the RS 5000 product literature and was distributed along with other product literature to Celotex's customers, including, in the case of the refurbishment, Harley. Criticism has been levelled against some of the Celotex product literature for referring to RS 5000 as being suitable or acceptable for use in buildings above 18 metres. Celotex submits that these criticisms are misplaced. References to RS 5000 being suitable or acceptable for use should have been read and understood in the context of each product document as a whole, alongside other statements made in the product literature describing the basis for RS 5000 suitability for use in buildings above 18 metres, namely that the product had been incorporated in a particular cladding system that had met the BR135 criteria by way of a BS 8414 Part 2 test. Any competent construction professional would have understood that RS 5000 suitability for use in any other cladding system needed to be separately assessed by the project designer. A competent construction professional would have properly understood the building regulations and guidance and read the RS 5000 product literature against that background, carefully and in full, and not relied on single words in isolation and out of context. Furthermore, the suitable for use language in the RS 5000 product literature must be understood in the context of the growing use of desktop studies at the time RS 5000 was launched. By August 2014, desktop studies had become a common method for verifying the compliance of a cladding system. Prior to launching RS 5000, Celotex had been advised by the BRE that widening the scope of application of a BS 8414 test via field of application reports, as desktop studies were also known, was standard practice. Advice to similar effect was given to Celotex by specialist fire consultants, as well as by the National House Building Council. And in this context, RS 5000 was suitable or acceptable for use in buildings above 18 meters, so long as Celotex warned, the building designer considered the effect of changes to the components with which RS 5000 had been tested and obtained any necessary assessment in relation to those changes. Now, Celotex recognizes, as it has from the outset of this inquiry, that the cladding system in which RS 5000 had been successfully tested in May 2014 was misdescribed in the RS 5000 product literature and in the test classification reports published by the BRE. In particular, those documents omitted reference to the use of thinner cladding panels at certain levels of the test rig, behind which was installed a layer of magnesium oxide board. This misdescription was previously unknown to Celotex's current management. The issue was identified in the course of Celotex's own investigations following the Grenfell Tower fire. Once established, the issue was reported in January 2018, prior to commencement of the Phase 1 hearings, to the inquiry, to the Metropolitan Police, to Trading Standards, to the Ministry of Housing, Communities and Local Government, and to the BRE. The issue was also publicly announced on Celotex's website, and steps were taken to notify customers, contractors and developers known to have used RS 5000. And desktop study providers were also notified insofar as they were known to have been provided with copies of the BRE reports. Celotex reiterates its acknowledgement that the misdescription of the tested system in the product literature and the BRE reports involved unacceptable conduct on the part of a number of former Celotex employees and should not have occurred. However, this misdescription had no causative impact on the specification and use of RS 5000 at Grenfell Tower. There is no evidence that any construction professional involved in the refurbishment read, let alone relied upon, the description of the tested system in the product literature or the BRE reports. Indeed, as I've already explained, the evidence before the inquiry shows that none of the construction professionals read or relied upon those documents in any meaningful respect at all. The misdescription of the tested system did not therefore affect the way in which the cladding system at Grenfell Tower was specified, designed, or constructed. Even if the construction professionals had compared the system described in the RS 5000 product literature or the BRE reports with the system proposed for Grenfell Tower, it would have been apparent to them that the system described was so substantially different that it could not be relied upon to justify compliance of the system at Grenfell Tower. No competent construction professional could have relied on the system described in the product literature and BRE reports to validate compliance of the very different system designed and constructed at Grenfell Tower. Celotex has taken concerted steps to enhance its procedures and processes since the issues concerning the testing and marketing of RS5000 came to light. This has been explained by Celotex in its evidence and in previous submissions. Celotex has provided further detail of the steps it has taken in a witness statement provided to the inquiry on the 1st of November in response to the inquiry's request for statements from core participants about work undertaken since the fire. The steps taken by Celotex include the recruitment of new technical and operational management, implementation of additional training procedures, introduction of a new quality assurance system, and improvements in Celotex's testing processes and procedures. In addition, as previously explained to the inquiry, Celotex commissioned another BS 8414 test, replicating as closely as possible the system described in the RS5000 product literature and BRE reports. This test showed that the retested system met the BR135 criteria, thereby confirming that RS5000 could safely be used in the system as described in the product literature in accordance with the statutory guidance in force at the time of the refurbishment. The BS 8414 tests carried out by the government following the Grenfell Tower fire also confirmed that RS5000 could safely be used in the cladding system with an appropriate combination of other materials. The government test of the cladding system incorporating RS5000 behind ACM cladding panels with an A2 rated core was shown to meet the BR135 criteria. I turn finally to the expert evidence as to external fire spread. Professor Bisbee's Module 7 evidence and the testing program that underpins his conclusions confirmed that the external spread of fire at Grenfell Tower was driven by Arconic's Rainabond ACM cladding panels and not the insulation behind those panels. Professor Bisbee's Phase 2 work fully corroborates the finding in the inquiry's Phase 1 report that the principal reason for the spread of fire up, around and down the tower was Arconic's Rainabond ACM PE cladding panels. As Professor Bisbee said, Rainabond ACM PE is a uniquely hazardous product that presents extreme fire hazards and should never be used on building facades. The product is clearly incapable of complying with the functional requirements of the building regulations. Rainabond ACM PE contains a core of polyethylene, which is highly combustible and, as Professor Bisbee explained, melts, drips, and flows whilst burning at an elevated temperature. The heat of combustion of the polyethylene core is comparable to that of diesel fuel and is the highest of all materials used on the cladding facade at Grenfell Tower. The polyethylene core will ignite at comparatively low heat fluxes, meaning that it would ignite in almost any cladding fire scenario. Of all the products used in the cladding system at Grenfell Tower, Rainabond ACM PE had the largest potential to contribute to the spread and growth of fire and was the largest contributor to energy release within the cladding system on the night of the fire. By contrast, RS5000 does not melt and drip when it burns. Rather, it chars and has a comparatively low heat release rate. It also releases energy over a greater period, whereas Rainabond ACM PE burns very quickly and vigorously. That is one of the reasons why Rainabond ACM PE is a uniquely hazardous product. In Professor Bisbee's words, Rainabond ACM PE is a very, very burny material. There are few construction products intended for use on the outside of a building that Professor Bisbee had ever seen burn with such intensity. He explained that every time he ran an experiment to full escalation of Rainabond ACM PE, he was surprised and alarmed. Rainabond ACM PE is especially lethal in cassette form, as was installed on Grenfell Tower. Professor Bisbee explained that the inside of each cassette provides a perfect container for collecting melting and dripping polyethylene. This creates a very efficient system for, in Professor Bisbee's words, the worst possible fire, by providing a mechanism for collecting pool fires within the cladding. Those pool fires then have the effect of generating upwards fire spread. In the light of Professor Bisbee's thorough analysis, his conclusion that Rainabond ACMPE and not the insulation in the cladding system was the primary and dominant cause of the spread of fire at Grenfell Tower is unassailable. The evidence is absolutely clear. Molten and dripping polyethylene from burning Rainabond ACMPE drove the fire up, around and down the tower. The combustibility of the insulation in the cladding system played only a minor role in the vertical spread of fire and no direct role at all in the horizontal and downward spread of fire. The horizontal and downward spread of fire at Grenfell Tower was the direct consequence of the presence of the crown at the top of the building. That was comprised of fins of Rainabond ACMPE with no insulation. And as the chairman found in the inquiry's Phase 1 report, and as Professor Bisbee explained in his evidence, the crown provided a mechanism by which the fire could go around the building. As it did, the melting and dripping polyethylene from the Rainabond ACMPE flowed downwards, igniting fires low down the building, which then traveled back up the building, thereby allowing the flame front to progress diagonally across each face of the tower. RS 5000 had no direct involvement in that process. The horizontal and downward progression of fire was simply a manifestation of molten polyethylene flowing downwards from the top of the building. The horizontal and downward fire spread would not have occurred without Rainabond ACMPE. Even as regards vertical fire spread, the role played by insulation was hugely overshadowed by the Rainabond ACMPE cladding panels, which were by a considerable margin the most important factor in vertical fire spread. In Professor Bisbee's view, the contribution from burning insulation to vertical fire spread was less than 10% and could have been as little as 2%. Professor Bisbee further showed that substituting non-combustible insulation for RS 5000 in test rigs with Rainabond ACMPE made no material difference to the speed of the spread of fire. Indeed, test rigs with non-combustible mineral wool insulation grew to full involvement of the Rainabond ACMPE more rapidly than those with the foil-faced combustible insulation products. This accords with the results of the government's BS 8414 testing of ACMPE cladding systems after the Grenfell Tower fire. Those tests failed to meet the BR 135 criteria, irrespective of whether the insulation was combustible or non-combustible. And indeed, the system tested with non-combustible insulation failed earlier than the system tested with PIR. It is therefore clear beyond doubt that the nature and speed of the spread of fire on Grenfell Tower was caused by Arconic's Rainabond ACMPE cladding panels and not the type of insulation behind them. Furthermore, any other insulation would have performed in much the same way or worse. Now, the evidence heard during Module 2 showed that Arconic knew years before the Grenfell Tower fire that Rainabond ACMPE was inherently dangerous, especially in cassette form, and that the product would not pass a BS 8414 test and was unsuitable for use on building facades. Arconic, however, failed to warn the market about these matters and continued selling Rainabond ACMPE in the United Kingdom on the basis of a BBA certificate and product literature, which, to Arconic's knowledge, misrepresented the product's true fire performance. Despite this, Arconic continues to protest its innocence before this inquiry. Those protestations, should Celotex submits, be rejected. The evidence against Arconic is overwhelming. That evidence is recounted in Celotex's written submissions and the submissions of other core participants. Celotex agrees, as stated by BSR Team 1, that the evidence of Arconic's knowledge of the true performance of its cassette panel is damning, and that Arconic's knowing deception of the BBA and of the design team working on the refurbishment makes it primarily responsible for the spread and growth of fire at Grenfell Tower. Other entities who share responsibility for the spread and growth of the fire comprise the construction and building control professionals I have mentioned, including in particular Exavo Studio E, Ryden, Harley, and RBKC Building Control. In conclusion, sir, Celotex wishes to thank the panel and the inquiry legal team for the care and diligence with which they have approached their task. Celotex has sought to play its part in ensuring that this inquiry helps to bring about effective and lasting improvement in the building safety regime and in construction standards. Celotex looks forward to the inquiry's final report and in continuing its own role in improving competency and culture in the construction industry. Thank you.
Thank you very much, Mr. Orr. The next statement is going to be made by Mr. David Sawtell on behalf of the British Board of Agrément. We're running slightly ahead of programme, but that is never a bad thing. But Mr. Sawtell is here and he's, I think, ready to address us.
Thank you very much.
When you're ready, Mr. Sawtell.
Mr. Chairman, Madam Sir, I represent the British Board of Agrément and I'm here to provide you with my oral closing submissions. And at the outset, the BBA expresses its deepest sympathy to the bereaved and to the survivors of the Grenfell Tower fire. Throughout, the BBA's concern has been for the bereaved and survivors and to do everything that it can to improve building safety and to ensure that a tragedy of this nature never happens again. To the extent that the BBA made errors and mistakes, it offers an unreserved apology to those affected by the Grenfell fire and its aftermath. As an organisation, the BBA is committed to improving the safety of buildings. That was its original founding purpose and remains central to the service that the BBA provides. To achieve this aim, and in light of the tragic events of the Grenfell Tower fire, the BBA has carried out a number of deep reviews of the way in which it operates. These changes reflect the findings in the Hackett report and also the evidence provided in this inquiry. The BBA aims to ensure that its agreement certificate, a mark of product excellence based on rigorous national and European standards, provides reassurance in today's highly complex construction environment. The BBA has fully engaged with the inquiry in an open, cooperative and transparent manner, and it will analyse your report with considerable care. These steps, sadly, though, cannot turn back the clock. The BBA's focus now is on doing what it can to improve its services, to enhance safety and to prevent a recurrence of a tragedy of this type. Firstly, I'd like to outline the background to the BBA. The founding purpose of the BBA was to provide an independent, authoritative source of data on the performance of construction materials and their suitability for use in clearly defined applications. The BBA's aim and purpose was and remains to enhance safety within the UK construction industry. The BBA was established to accelerate the building of housing, in particular, through the use of innovative methods and materials in a safe and sustainable manner. The Agrément Board became the BBA in 1982, coinciding with its change of legal status. is now one of a number of certification companies in the UK, and since 1983, the BBA is no longer formally part of the UK government. However, its original remit remains. The BBA enhances safety through its work, researching, auditing, inspecting, testing, and certifying products. The BBA now operates as a self-funding, non-profit distributing company limited by guarantee, with no formal government association. It has no shareholders and does not distribute profits. Any profits made by the BBA are used for the benefit of the construction industry or the public good. And while the BBA has introduced a range of services over the years, it remains best known for its Agreement Construction Product Certification Scheme, which we know as the Agreement Scheme. And that scheme and its certificate allows new and innovative products to be brought to market which are safe and fit for their purpose before bespoke standards have been developed. I would outline why there are a range of reasons a recognised UK product certification scheme is and remains of fundamental importance to construction safety. Firstly, it is a third-party opinion. The certificate states the BBA's opinion as to a product's fitness for purpose, including its compliance or contribution to compliance with the building regulations as noted in that certificate. The Agreement Scheme's primary function is to determine the safety of a product. In addition, it also assesses a number of performance criteria, such as structural performance, thermal performance, durability, strength, and of course, fire performance. This review is voluntary for construction industry participants, and from an industry perspective, it adds a level of additional assurance about product quality and safety. This leads into the second point, that of supply chain assurance. Especially today, much of UK's construction material is imported. This is unlikely to change in the near future. The failure to so certify products could increase the risk of imported products not meeting stringent safety demands, standards and regulations of the UK construction industry. A product certification scheme gives confidence in the supply chain to designers, specifiers and contractors that products have been assessed against UK regulatory standards. Thirdly, it has a number of uses. The Agreement Scheme is regarded as the primary construction product certification scheme in the UK construction industry. It is referenced by users such as warranty providers, specifiers, and insurers, alongside other important sources of information, such as the building regulations and approved documents. BBA certificates state the BBA's opinion as to a product's compliance or contribution to compliance with the relevant building regulations, but they do not themselves demonstrate compliance for a particular installation. It is not a legal requirement to hold a BBA certificate. In many instances, the inquiry is heard that the certificate is seen as a marketing tool. It has been relied upon by industry professionals and used by product marketers because of their confidence that the BBA's experts would grant a certificate in terms that the BBA felt was most appropriate, specifically on terms that demonstrate a product's compliance or contribution to compliance with building regulations. And fourthly, the fourth point I would make is the facilitation of innovation. The BBA often addresses innovation, both for products and the circumstances for their intended use, or both. And consequently, the BBA is set up to design and execute, where necessary, bespoke tests and assessments, and to make professional judgments based on its findings. This is particularly helpful in innovative circumstances where standards and regulations have not yet been developed, and yet assurance of product suitability and/or safety is still necessary. Over the course of 6 decades, the BBA has built up an extensive and in-depth industry and construction product expertise and track record. The staff of BBA engaged to assess construction products typically have a high level of formal education, while staff also develop extensive knowledge of product-specific performance standards. I'd now like an outline to set out the context to the work the BBA undertakes. And there are some important elements in that context for the BBA's work, particularly in the time period the inquiry has been considering. Firstly, the BBA's relationship with an applicant for a product certificate is contractual. The BBA has no powers to compel any client company to act or not act, save within that contractual framework. Secondly, the BBA was not, at the time of issuing the certificates being relevant to the inquiry, aware of any client company supplying the BBA with false information. The BBA was therefore not on notice of or structured organisationally to prevent a possibility of misrepresentation. And we refer to that further in our written closing submissions. The steps are taken to the BBA since then. The BBA does not have, thirdly, any role to play in setting safety standards in relation to building regulations and the approved documents. The BBA simply assesses the products against those standards and the contents of the documents, and those are beyond the BBA's control. At present, there is no formal consultation process concerning standards involving the BBA. And again, that is a point the BBA addresses in its submissions on recommendations. Fourthly, the BBA is run as a private organisation. It has been for several decades, and that is a conscious decision that was taken by a previous government. Fifthly, and finally, the BBA is a small organisation. It operates out of offices in Watford and Liverpool, with a testing facility as well in Watford. It is fully privately funded. Its capabilities are limited by the scale of its operations and the size of its contracts. It is the BBA's position that each of these factors are outlined are relevant when determining the role the BBA plays in the wider safety ecosystem for building products. I'd now like to turn to consider oversight and management. The BBA is regulated by the United Kingdom Accreditation Service, or UKAS, and UKAS is the UK's national accreditation body, which is responsible for determining, in the public interest, the technical competence and integrity of organisations, such as those offering testing, calibration, and certification services. The BBA's overarching processes and operations have been sufficient for it to receive approval from UKAS throughout the period in question. UKAS accreditation is not mandatory for certification bodies. It provides a further degree of assurance as to the quality of BBA certificates. It demonstrates the competence, impartiality, and performance capability of those providing accreditation. The progress of the inquiry, however, has highlighted a number of the areas in which the BBA's processes could improve. The BBA has always been seeking to make improvements, and since the Grenfell fire, it has made a number of important changes. Just to focus on two parts in respect of oversight and management. Firstly, in respect of training, the BBA has always employed suitably qualified and experienced individuals. The effectiveness of the BBA's training and competence for staff involved was examined and approved by UKAS during assessment audits. A significant amount of staff training was and remains on-the-job training, that is specific to the job function and the technical area of business where each individual's work is focused. Initially, staff are assigned a narrow field of operation because the BBA assesses many hundreds of different product types. Training requirements are therefore bespoke. Staff have responsibility for just a few materials initially, under the supervision of a more experienced project manager, and the BBA focuses on training being delivered within teams. And in addition to this on-the-job training, the BBA provides in addition formal training by way of presentations by experienced staff on relevant technical subjects. In 2017, a human resources manager with a training background was recruited. And in 2019, a learning and development manager was inducted to formalise the training of staff as they were onboarded. The second point I would flag at this stage is fire testing. A BBA is not a fire laboratory that carries out fire testing. It takes the results of UCAS accredited fire tests and assesses those against the requirements of a document supporting the national building regulations. The BBA acknowledges that between 2004 and 2010, there was no appointed in-house fire expert within the BBA. The BBA was of the view that the technical manager at the time, Brian Haynes, had sufficient knowledge of fire in the context of the BBA's activities, and then subsequently John Alban and John Denyer in respect of the requirements of Approved Document B. External fire advice was obtained on occasions where an issue was outside the knowledge or expertise of the BBA staff. The BBA recognised the need to formalise this external fire expertise. It entered into a consultancy agreement with Exover Warrington Fire in February 2010. A new role of technical coordinator for fire was set up in 2014 to facilitate liaison with external fire experts, and in particular to act as the BBA's contact for the operation of the agreement with Exover Warrington Fire. And now I'd like to turn to the core of the BBA's services, and that's certification. Certificates are intended for use by specialist, trained, and qualified designers and specifiers. Their content and format reflect this. A certificate should be used as one part of a larger exercise to determine whether the requirements of the building regulations, as well as other technical standards, such as those produced by NHBC, will be met in a particular use case. Neither a BBA nor a BBA certificate certifies a particular building or part of a building. One of the central themes that has emerged from the evidence before the inquiry has been the importance of considering the building as an overall system and structure for the purposes of fire safety. The properties of one product is one element of that system. Similarly, the result of a reaction to fire test in respect of that individual product can inform a designer's judgment as to whether or not to specify a product. However, a view on the overall fire safety of a product cannot be taken in isolation from a selection of other materials and components, the detailed and overall design, and a large number of other factors. So when we consider how to use a BBA certificate does not purport to inform a designer in respect of the overall design of a building. Instead, the designer of a structure must make an informed decision, taking into account a range of factors, including the performance of that product and the use of a particular material within a wider structure. It would not be possible for a certificate to comment on all potential uses and product configurations and building designs. Instead, it provides a reputable and technically qualified third-party opinion on the ability of a product to achieve a particular standard referred to within the national regulatory framework, based on testing carried out by UCAS accredited testing houses. Test data is provided so it can be used by designers on the basis of requirements of a given installation, in view of the requirements of that prevailing regulatory regime. The designer can then make an informed decision about the properties of a product, including whether or not further information is required from a manufacturer or by procuring further testing. Certificates are reviewed every 3 years, necessary updates are identified, and they should then be followed by a reissue to incorporate them. And the BBA accepts that in the past this was not always followed up. This is an area of weakness that has been identified by the inquiry, and the BBA has now put in place a policy that no certificate should be more than 3 years old. Reissues can also be undertaken at any time between reviews, should the need be identified by the certificate holder or the BBA. My next point I submit is critical. The front page of a certificate, any certificate, can only be a summary of the more detailed content within the body of the certificate itself. the BBA has been consistent in its submission that a certificate should be read in full. This would be expected of any qualified building industry professional. It is only by reading the certificate in full that all information relevant to the use of a particular material can be known by the individual relying on the BBA certificate. No conclusions should be drawn from the front page of a certificate alone, or by relying on any other section in isolation. A BBA considers it is correct to criticise a professional designer who fails to carry out the basic step of reading an 8-page certificate in full, or alternatively, to have even followed through a reference on the first page through to a half-page reference on behaviour in respect of fire. This minimum should be expected of a reasonably competent specifier or designer. Having set out certification more generically, I now intend to consider the position of Arconic. And we've heard throughout this inquiry the BBA dealt with Arconic Architectural Products, SAS, formerly Alcoa Architectural Products. First of all, the certificate itself. The BBA's information comes from prospective certificate holders. The Alcoa application form, the information provided with it, and any further information provided by Alcoa are important when considering the eventual wording of the resulting certificate. At the time of the assessment by the BBA, Alcoa was aware that the cassette version should have been classified as Class E. Alcoa also had a report at the same time that showed the riveted version of Reynobond's product was Class B. But it was only the latter report that was submitted to the BBA. Alcoa did not advise the BBA that the two installation methods of the product had manifestly different reaction to fire properties. Again, the BBA asserts that had this test data been in the BBA's possession, it would have had a material effect on certification. And when Alcoa was presented with draft certificates by the BBA, it did not correct them to show that there was this very significant difference between the riveted and cassette versions. Alcoa never provided this information to the BBA before the Grenfell Tower fire. I'd now like to call up as a document the contract between Alcoa or Arconic and the BBA. That is BBA reference BBA 000-10725. And in particular to look at page 3. If it's possible, I'd like to zoom in to clause 7. Thank you. And we're looking at clause 7A, where it says the applicant shall disclose to the BBA full particulars of and relating to the subject, including, but without prejudice to the generality of the foregoing, and we go through any test data already available and of the test procedures used to obtain the same provided. And then if we go on to G, to immediately notify the BBA of any change in a particular supplied to the BBA or any third parties. Those simple requirements were not complied with. Arconic withheld fire test data in relation to the cassette version of Reynobond 55 polyethylene in breach of contract with the BBA. I'd now like to call up the Reynobond certificate itself. And that is reference BBA 00008062. I'd like firstly to turn to page 3 of the certificate and to look at technical specification. There we can see it is described as being available as being either plain-edged, riveted system or flanged cassette system. It's also stated the products are available in a fire retardant grade. So the first part, Section 1 of the detailed contents of a certificate, tells the reader about different versions of a product with different reactivity to fire properties, and one of them is fire retardant. I'd now like to turn to Section 4, if I may. That's on the, page 4, Section 6, my apologies. If we go, onto page 5. If we zoom into behaviour in relation to fire. And this is a detailed but relatively short section. First of all, BBA understands that Rainer bond cladding used on the Grenfell Tower had a smoke silver or pure white Duragloss surface coating. Noted in paragraph 6.1 of the certificate, a fire test provided for BBA was actually in respect of a grey-green Duragloss coating. We go on to look at section 6.4. It says, these performances may not be achieved by other colours of the product. Therefore, the Rainer bond cladding used in refurbishment of Grenfell Tower was not covered by a BBA certificate, as it did not cover the colours of the product actually used on the building. If we look at paragraph 6.2, as I've noted previously in respect of the first section, a specifier or designer on reading 6.2 would have become alert to the availability of a fire retardant option. If we then look at section 6.3, first of all, it refers back to section 6.1 and section 6.2. And it is only by reference to, and it says expressly, in relation to approved document B, that is stated that products may be regarded as having a class 0 surface. And the inquiry may recall the question as to parallel references to class 0 and Euro class B that arise in diagram 40 and paragraph 12.6 of the approved document B. Just pausing there, diagram 40 refers to class 0 national class or class B minus S3, D2 or better European class. BBA would submit that for the purpose of diagram 40, therefore, the two standards were treated as equivalent, although in reality we know that they are different. Section 6.5 of the certificate states that for resistance to fire, this performance of a wall incorporating the product can only be determined by tests from a suitably accredited laboratory and is not covered by this certificate. The certificate expressly does not certify the wall incorporating the product. Instead, the professional designer is directed to consider a relevant test. At 6.6, the certificate clearly emphasises the importance of incorporating cavity barriers, as required, of course, by the approved document. My concluding point, then, is on reading the full Section 6, a professional designer would have deemed it appropriate to seek further guidance on issues as to whether they should specify a product with a fire retardant core, whether the colour they are proposing would meet either National Class 0 or European Class B or better. It's very clear. The certificate is not evidence of the performance of a product in all different configurations. It's as essential, as I've outlined before, the certificate is read as a whole, including the caveats that it contained. A properly experienced and competent individual reading the certificate would need to be aware that the performance of a particular component would depend on the performance of adjacent components. So there is the certificate. Let's consider the position after certification. The BBA was not advised of any significant changes to the specification of a product during the lifetime of this certificate. We can consider, I would simply note, the reissue contract of November 2016 at clause 10A required Arconic to disclose full particulars of and relating to the subject, including any test data or other relevant data. Arconic did give details of minor changes to the product process, but critically did not provide the BBA with available fire test results that were in its possession and it had not previously provided to the BBA. This was fundamentally misleading. It was, again, in breach of Arconic's contract with the BBA. I would now like to turn briefly and to outline immediate actions following the Grenfell Tower fire. Those are set out in the first witness statement of Brian Moore, the former Executive Director of the BBA, and the first witness statement of John Alban, the Head of Approvals for Construction Products. And they set out the information that was not provided to the BBA. Those witness statements were volunteered to the inquiry, were not directed to provide them. I'd like to just briefly explain then the circumstances in which they came into existence. Following the Grenfell Tower fire, in the process of gathering evidence for the inquiry, the BBA was provided with advanced disclosure of Appendix O of Dr. Barbara Lane's report. We don't know why it was the inquiry decided not to disclose these documents before October 2018, but immediately from reading this report, it became clear that Arconic had been in possession of many more fire classification reports than it had disclosed to the BBA at the time of certification, during the review process, on reissue of a certificate, and after the fire. And upon the inquiry sending Dr. Lane's report and the fire test report referred to therein to the BBA entered into correspondence seeking urgent clarification from Arconic. As Arconic were unable to explain the failure to provide this information to the BBA satisfaction, the certificate was suspended on the 16th of November 2018, and it was subsequently withdrawn on the 24th of February 2019. If the information that had been available to Dr. Lane had been made available either during the application process or afterwards, the certificate would either have been reissued or amended to reflect the distinction between the fire retardant polyethylene cord product and the riveted and cassette forms of the product. The BBA simply does not know whether Dr. Lane has been provided with the witness statements of Brian Moore or John Alban that are provided in October 2018, and Appendix O has not been amended in light of what we now know, what the inquiry now knows, was the state of the BBA's knowledge at the time of certification. And I would ask inquiry, when considering Dr. Lane's report and her recommendations, to read that in light of the fact the information before her as to the state of the BBA's own knowledge had limitations. All of this draws together a larger point. The agreement scheme is a voluntary scheme. It has been used to great effect over 60 years. As it is not a legal or regulatory requirement, it does require participants to be open and honest. If a participant is not, there are contractual sanctions. What the evidence before the inquiry has demonstrated is that the applicants to such voluntary schemes have withheld information which would be highly relevant to the product certifier. The BBA has changed its processes as a result of this. The outcome of the agreement consultation, which has been set out in our submissions from the 31st of October 2022, has been to accept its recommendations, which have been designed to avoid a repeat of these incidents. And I'd like to turn on to Kingspan and the Kingspan K15 certificate. And the inquiry will recall that the K15 certificate went through a number of reissues from 2008 to 2013 before a new certificate was issued in 2015. All of the Kingspan certificates, came with the following warning, that it has to be read considered and used as a whole document. It may be misleading and will be incomplete to be selective. However, the material wording of a certificate has changed on each occasion, and the inquiry will recall Mr. Alwyn was asked questions by counsel to inquiry in respect of that, and I don't intend to go through that evidence in any detail. The version of the inquiry has spent most time on is amended issue 1, issued on the 6th of April 2010. And I was asked at this stage for the document BBA 0000037 to be placed up on screen. It's noteworthy that although it is dated April 2010, it was not in fact placed into the public domain until the 12th of July 2013. It was then replaced by issue 2, which was issued on the 17th of December 2013, and therefore this certificate was only in circulation for less than 6 months. I'd now like to go into some of the wording, in particular in respect of approved document B that this certificate refers to. Can we please look at page 5 of this document? If we can zoom in, please, to section 7.1. And in particular, where it says England, and it says this product may therefore be used in accordance with provisions of England and Wales, approved document B, and at the end, paragraph 12.7. And the inquiry will recall paragraph 12.7 of approved document B. In a building with a story 18 metres or more above ground level, any insulation product, filler material, not including gaskets, sealants and similar, etc., used in the external wall construction should be of limited combustibility, full stop. Then it goes on to say, this restriction does not apply to masonry cavity wall construction, which complies with diagram 34 in section 9. The point being, there are two parts to this paragraph: a general prohibition on the use of certain materials which are not of limited combustibility in a building with a story 18 metres or more above ground level, and an exception for masonry cavity wall construction. K15 was therefore suitable for use in some applications within paragraph 12.7, such as a cavity wall where the product is flanked on either side by non-combustible concrete bricks or blocks. And I note that during the inquiry, a number of Kingspan's witnesses were asked questions in respect of this reference to paragraph 12.7. As I would suggest, however, the second part of the sentence makes it clear the restriction does not apply to the certain masonry cavity wall constructions. The BBA does, however, accept, and it did accept during evidence, that this wording was allegedly open to interpretation, and with the benefit of hindsight, it was capable of being tightened. And indeed, as we recall, it was removed. However, at no stage did the K15 certificate state the product was of limited combustibility. A technically qualified reader reading the certificate alongside the full paragraph 12.7 would know that K15 could not satisfy clause 12.7 for a rain screen construction above 18 metres, as it was not of limited combustibility. As Mr. Robin made clear, if a BBA considered that a product was of limited combustibility, this would have been stated clearly. So a technically qualified reader reading the certificate alongside paragraph 12.7 would know that it could not satisfy such a construction. As I said, Mr. Alban was clear. It was a statement that was allegedly capable of misinterpretation, but it was never stated it was of limited combustibility. I also note the warning contained in the certificate about the need to contact the product manufacturer for buildings with a floor above 18 metres ground level was retained at paragraph 7.2. Mr. Chairman, I'm going to move on to another topic now, but I note the time.
Would that be a convenient moment to take a break?
Absolutely.
Right, thank you very much. Well, we'll break at that point, therefore, and resume, please, at 12:15.
Okay.
Thank you very much. Yes, Mr. Sawtell, are you ready to carry on?
Indeed, Mr. Chairman. I have three more substantive sections before the close of my submissions.
Yes,
Firstly, I want to go through Brian Martin's correspondence in July 2014, then relationship with UCAS, and then the largest of the last three sections, organisational changes in the BBA. A short section was in respect of correspondence with Brian Martin in July 2014. That is contained in a document at BBA 000-00178. And could I ask we turn to page 3, please? And this is the start of an email chain between Brian Martin, an official at the Department of Communities and Local Government, and the BBA in July 2014. It was in respect of that paragraph in the Kingspan K15 certificate that we had been considering. And it has transpired from evidence within Module 6 that the matters of which Mr. Martin was writing was a more generally held concern about the wording of the reference to paragraph 12.7. The point for the BBA is the extent to which this concern was more widely held and significance of it was not set out in this email, and the BBA was not aware of the significance of the point at that time. If we return to that chronology in the Kingspan K15 certificates, the wording on the Kingspan certificate had already been removed in issue 2, which had been issued in December 2013. And what the email chain shows, if inquiry will recall, is that John Albin provided Mr. Martin with an explanation as to how this had come about. The point I would highlight in these closing submissions is that the BBA invited Mr. Martin to a meeting twice, and twice this invitation to a meeting was declined. And as a consequence, it was not communicated to the BBA that this was seen to be a more widespread concern. And this was an unfortunate misunderstanding between Mr. Martin and the BBA. What I'd note is that Mr. Albin's response and this line of correspondence raises a more general point. What should be the relationship between central government and a product certification company when it comes to issues of construction safety? And the policy in 2014 was that Mr. Martin did not consider it appropriate to meet with the BBA about this issue. One of the points the BBA has flagged in its submissions is it is suggested that the future relationship between entities involved in building safety and the government need to be revisited. Just to finalise the point in respect of K15 before I move on to the next substantive part of our closing submissions. As we recall that in the 30th of October 2020, Kingspan wrote to the BBA to state it would be withdrawing 3 BS 8414 test reports from circulation. And so at that time, the Kingspan certificate was suspended in accordance with the BBA's procedures. And so product sheet 7 of the certificate for K15 was suspended. The BBA investigation concluded that the previous suspended certificate could no longer be relied upon, so product sheet 7 of the certificate was withdrawn on the 25th of November 2020. And then as part of a long-term existing project to update the K15 certificate with new fire data, a new product sheet 9 was issued to Kingspan K15 on the 24th of November 2020. And that product sheet was given a new number so as to differentiate it from that which had originally been issued. So moving on from Kingspan K15, the issues that arise from that certificate, and turning now to UCAS, which, as I outlined at the outset, is the UK's national accreditation body, which accredits conformity assessment bodies against national or international standards. And this includes fields such as the testing, inspection, and certification of products. Once again, the relationship between UCAS and an accredited body, such as the BBA, is contractual. In the immediate aftermath of the Grenfell fire tragedy, the BBA was subject to 2 UCAS audits, which were specifically examining the BBA's assessment and certification of ACM materials. The first considered the records associated with the initial certification and subsequent triennial reviews, and the second included an examination of the processes leading to reissue of Certificate 08/4510, so Rhino Bond, and also covered the assessment and certification of all other ACM materials. UCAS deemed those to give confidence in the review process that had been conducted by the BBA, and they stated it was a robust assessment. As we've set out in our written submissions, the inquiry should have confidence that the UCAS assessment in July and August 2017 was properly carried out in accordance with UCAS's procedures and policies, and of course was based on the information known to the parties at the time. The BBA has been, and it continues to be, very happy to work in collaboration with UCAS in the future development of the accreditation of the agreement scheme, and that's something which we set out in more detail in our 31st of October 2022 submission. I would like to turn to one discrete point regarding the immediate reaction to June 2017, the steps the BBA take. And this arose out of questions which were not put to BBA witnesses, but were put to Lorraine Turner of UCAS. That was on the 7th of February 2022. If I can ask for the transcript for day 227 to be displayed. If we could turn, please, to page 136. And if we could, this is in relation to a document. We see at line 6, we have a document from UCAS file for assistant from Nexova. It says towards the bottom, we shall see an email from Nisha Sharma of the BBA, and she's emailed Janet Mull and Andy Kearns of Nexova. And we'll look at this document in just a moment. Can we turn to the next page, please? And we can see that from this extract in the transcript, it says Nisha will go on C, being a member of staff of BBA, our opinions are based on test evidence, interpretation of standards and regulations, and also expert judgment. If we could please turn over onto the next page. Lines 4 to 7, counsel to the inquiry said it might be said in this exchange the BBA was not making a genuine inquiry about the certificates. It was updating. It was just covering itself. Do you agree with that? And Ms. Turner, and I would submit quite appropriately, says that she can't really comment on the motivation for the question. If we look at this email exchange, if I can ask, please, if we turn to document UCAS 0001080, and we turn first of all to page 3. So indicated Nisha Sharma was the member of staff at the BBA who was engaged to liaise with Warrington, or Exover Warrington Fire, the external consultant that the BBA had engaged in respect of fire testing and fire standards. And Nisha Sharma there, we can see, is in 14th of July 2017 is writing, you have provided your opinions and comments on assessment of fire performance of various constructions In light of a recent fire incident, can you please confirm you'll stand by these opinions? Can we turn now, please, to page 2? A response from Exova is at the bottom. And it says, NISHA, our opinion is based on test evidence, interpretation of standards and regulations, and also expert judgment. Exova Warrington Fire confirms that our responses to your questions were, in our opinion, correct at the time of provision. No witnesses from the BBA were asked to comment on this document. It is a serious allegation. It would be unfair, I would submit, to accept that insinuation that was made in that moment in circumstances where neither Mr. John Alban, nor Mr. Moore were actually asked about this email exchange. The evidence from the BBA, when Mr. Moore was asked about this in evidence, he explained was that the BBA had a consultancy agreement with Exova Warrington Fire. And BBA has asked Mr. Alban to comment on the question that was put to Ms. Lorraine Turner of UCAS by counsel to the inquiry, which was not put to Mr. Alban himself. He has suggested that he was ensuring the judgment made on the basis of opinions given by Exova Warrington Fire had remained valid and safe. Of course, if Warrington Fire had not indicated that was correct, a BBA would have been required to reassess and potentially reword certificates, with the obvious consequence for installations based on the original certificate wording. And I would submit that the steps taken by the BBA in July 2017 to reach out to Exova Warrington Fire and to ask them to confirm their previous opinions was appropriate and a responsible step for the BBA to take, and I'd ask that the inquiry does not make an adverse finding in respect of the BBA on that point. I'd now like to turn to the last substantive point for the BBA, and it is in respect of organisational changes. Since the Grenfell Tower fire, the BBA has carried out a root and branch review of its organisation and delivery processes. This includes the appointment of a new governing body in 2019, significant changes to the management structure and team, and a redesign of the way in which the organisation works. This was carried out in consultation with UCAS. The BBA has made changes to its internal processes, the wording of its certificates, and the training provided to staff following the Grenfell Tower fire. A significant amount of technical staff time is in particular devoted to building technical knowledge. And in the submissions dated the 31st of October 2012, the BBA set out the numerous steps that it took in the immediate aftermath of the Grenfell Tower fire in 2017. These included the following. Firstly, an immediate review of all certificates relating to materials or circumstance of use of products with similarities to those used on Grenfell Tower. Building its human resources team to increase focus on learning and development. And as I previously indicated, in 2019, a learning and development manager was appointed to further formalise the training of staff as they are onboarded. An internal process review, giving specific focus to enhancing the quality of certification and the safety assurance it provides, and to increase the amount of staff time devoted to developing technical knowledge. The BBA has supported the government in its efforts to improve building safety, and to that end the BBA has engaged with Dame Judith Hackett's review of the building regulations and fire safety, and following the publication of the final report, the BBA agitated for a full adoption of the Hackett report's findings, which it enthusiastically endorses. In early 2019, Andrew Kitchingham was appointed as chair of the BBA. He immediately carried out his own review of the business, and in doing so, he identified the need for significant leadership changes across the organisation. And I submit there are changes that enable full business transformation. All but one of the directors were replaced. And in January 2020, a new CEO, Mr. Hardy Geisler, was appointed. Following the introduction of the new top management, the BBA has undertaken a root and branch review of operational management and delivery processes. The BBA's change programme, called Project Alpha, commenced in January 2020, and it dominated the internal agenda for a period of 2 years. It looked at all areas of performance, and it gave further impetus to the ongoing internal process review that it had initiated in 2017. And we would suggest that, importantly, Project Alpha gave the BBA staff a stronger and more impartial relationship with its clients. And further changes in 2019 and 2020 ensured fuller cooperation of manufacturers and to accelerate the BBA's reaction time to update certificates following the provision of new information. That process completed in December 2021, and immediately from that chronology, we can see running in parallel the process of the inquiry and the steps the BBA was taking. The BBA launched an industry consultation in 2021 on how the agreement scheme can be improved to address the specific requirements of higher risk buildings, predominantly focusing on strength and on fire performance, as well as other performance criteria. Taken together, the recommendations that ensued set out 5 or more years of work. And some initiatives, where there is a need for research, will inevitably go on for longer. And so the BBA has adapted its business plan accordingly. Following this process of internal review, the BBA has become keen to assist government and regulators to set standards and required processes for fitness for purpose and other forms of certification to maximise product safety. And the BBA has launched an independently chaired working group with cross-industry representation with this purpose. That group was launched in August 2022 and first met in October of this year. And the key objectives include bringing wider engagement with an understanding of certification across the market and to broaden access to certification and to maintain standards. Also note that BBA has also digitised its business to ensure its way of working is system-driven and system compliance is fully integrated into all of its products. The BBA set up an industry working group to work with others to increase the use of product certification and to set a high standard across industry for product certification. This is an ongoing process. An external party, Mr. Gus Carroll, was appointed to lead a review of BBA's internal audit in September 2022. He will report later this month. He was Chief Engineer at Centrica for 12 years, and his current role was Chair of the HSE's Control of Major Accident Hazards Strategic Forum and co-founder and CEO of Empiricus. The headline point is that in the period from 2020 to the end of 2022, a BBA would have spent the equivalent of 10 years of operating profit to transform the business. And this is the most significant level of change and investment experienced by the BBA since its inception in 1966. More details of those plans we have set out in our submission dated 31st of October 2022. This comes in the context of the changes which are highlighted and have been highlighted over and over again, of the need for change and change in the construction industry. That comes from the Hackett report. That comes from the Phase 1 report of this inquiry. It comes from the evidence to the inquiry during Phase 2. It comes from the Building Safety Act 2022 and the anticipated framework for product regulation that the new legislation incorporates. BBA has recognised this driving imperative for change, both in terms of its internal functions and systems, but also externally, as the Hackett report confirmed, changing the culture. I can come on to my conclusion. BBA has issued many thousands of product certificates since 1966, and the agreement scheme is seen as providing high-value content and contribution to industry. The inquiry has helped BBA identify areas for improvement, including by exposing unsatisfactory elements of its operations, which the BBA has responded to with vigour. The BBA operates a policy of continual improvement. It has already made significant changes and it fully intends to continue to make changes to work towards a higher standard of safety and quality for the construction industry. The inquiry has considered the BBA's processes for a span of approaching a decade, from circa 2006 or 7 up to 2017, and already by 2014 we can identify a number of changes had been made as to how it had operated from the outset of that period when Renault Bond and K15 were initially assessed for certification. Subsequent to this period in consideration, the BBA has made even more significant changes, reaching the end of the third year of its transformation programme. So the BBA has invested significant time to understand the changes required to make the construction industry and the buildings it produces a safer place. It considers that as an organisation, it has more to contribute to transformation of the UK construction industry with a new governing board and leadership team. And in particular, since 2019, when the wholesale management and cultural transformation of BBA began, the organisation has sought to learn what it can from the Grenfell Tower fire and to improve safety across the construction industry. And we hope this contribution will continue to accelerate. The Grenfell Tower fire brought into sharp focus the need for what Dame Judith Hackett described as a need for cultural change, and a need to create drivers for right behaviours in the design and construction of high-rise residential buildings. The enactment of the Building Safety Act 2022 has begun the process of adopting and implementation of the recommendations proposed in her final report, which the BBA has campaigned for. It is recognised, however, that it is only the start of the systemic change required. The BBA will carefully consider the outcome of the inquiry, and it will do what it can to support the improvements required in the UK construction industry. The BBA again wishes to express its condolences to the families and friends of those who died in the Grenfell Tower fire, to survivors of the tragedy, and to those whose lives have been affected. It considers it is our duty to ensure all lessons learnt are pursued and implemented to create safe spaces in which people can live and work. Thank you.
Thank you very much, Mr. Sawtell. The next statement is going to be made by Mr. James Maxwell-Scott, King's Counsel, on behalf of the Royal Borough of Kensington and Chelsea. So when we've done a little bit of housekeeping, Mr. Maxwell-Scott, we shall be ready to hear you. Right, when you're ready.
Good afternoon, Mr. Chairman, Ms. Istefan, Mr. Akbor. The Council is grateful for this opportunity to make a final overarching closing statement. In December 2017, the full Council unanimously adopted a resolution committing it to openness, transparency and candour in its approach to this inquiry. That commitment has remained constant over the last 5 years. The Council and its legal team have been conscious of it and guided by it throughout that period. It is not only a commitment to the inquiry, it is also a commitment by the Council to the bereaved survivors and residents, and to the people of Kensington and Chelsea whom the Council exists to serve. It was fitting that the first and last witnesses to give evidence at this inquiry were the bereaved survivors and residents. Their evidence was as powerful in Module 8 this summer as it was in the commemoration hearings 4 summers ago. The Council has been heavily involved in many of the Phase 2 modules. This reflects the fact that, as we stated in our Phase 1 opening statement, the Council was involved with Grenfell Tower and its residents in a number of different ways. We identified 10 in that statement. The Council made unqualified admissions in its Module 1 opening and closing statements. in its Module 3 opening and closing statements, and in its Module 4 opening and closing statements. The Council has reviewed all of its previous submissions. It stands by them and repeats them. It apologises unreservedly for its failings. The admissions made by the Council include the following. Building Control failed to ask for comprehensive details of the cladding system and issued a completion certificate when it should not have done. Residents were not listened to as much as they should have been. The number of council officers devoted to monitoring the TMO was insufficient, given the number of residents whose properties were managed by the TMO and the scale and importance of the task delegated to the TMO. There was no RBKC document setting out what its residual responsibilities were under the fire safety order in respect of properties managed by the TMO. The officers in housing commissioning who monitored the TMO received no training on the Council's residual responsibilities under the fire safety order. There should have been a self-closure inspection programme in place before the 14th of June 2017. My statement today is divided into two parts. The first part is about the cladding system installed on Grenfell Tower. The second part is about the fire safety measures within the tower. I will not be addressing you on aftermath-related issues. This is for two reasons. First, because Module 4 finished comparatively recently. Secondly, because those issues are essentially self-contained. They are clearly distinct from the pre-fire issues considered in the other modules. I turn now to the first part of this statement. On the 4th of August 2014, Studio E emailed the full plans application form to the Council's Building Controls Service. The Council admits, as it did in its opening statement in Module 1, that there were failings in how the Council's Building Controls Service dealt with that application. Building Control failed to ask for comprehensive details of the cladding system. Building Control failed to identify that the insulation materials used in the cladding system were not of limited combustibility and therefore did not satisfy the requirements of paragraph 12.7 of approved document B. Building Control issued a completion certificate on the 7th of July 2016. It should not have done so. None of the points which I am about to make are intended to detract from these unqualified admissions. The central theme of the first part of this statement is that the Council's Building Control Service should never have been in this position. It should never have been the case that a single local authority building control service was all that stood between dangerous products being used on Grenfell Tower. Neither Rainer-Bond PE55 or Celotex RS5000 should ever have been installed on Grenfell Tower, and the combination of those two products in a cladding system should never have got anywhere near Grenfell Tower. There are two strands to this submission. One, Arconic and Celotex took active steps to ensure that their products were used on Grenfell Tower, despite knowing that they were wholly unsuitable for use on a high-rise residential building. Two, there were multiple missed opportunities to prevent Grenfell Tower being clad with such wholly unsuitable products, opportunities that could and should have been taken. In our written closing statement, we have focused on 14 key dates, although many others could have been chosen. Today I'm going to narrow that down further and focus on 10. I'm going to structure my submissions chronologically and highlight 10 dates when we say events could and should have taken a different course. It is natural, following a tragedy of the scale of Grenfell, to try and identify the most important failings. The approach I'm about to take of honing in on specific key events is a logical approach to take. but it is important at the same time to keep an eye on the bigger picture, on themes as well as events. Immediately after the fire occurred, many commentators were keen to portray it in very largely local terms rather than national terms. I suspect that few people anticipated that the inquiry would need to hear so many days of evidence. But as the inquiry progressed, the importance of the national dimension became ever more apparent. The inquiry's list of issues had to be updated and expanded to include a specific issue relating to the testing, certification and classification of products used in cladding systems. This ended up with its own module, Module 2. In addition, Module 6, relating to the policy and regulatory framework set by central government, had to have its time estimate increased. In the end, these two modules, both of which focused exclusively on national issues, occupied 91 sitting days, and that doesn't include expert witnesses or opening and closing statements. Mr. Chairman, I have no doubt that when you embarked on this inquiry, you expected to identify a sizable number of failings. But even you may have been surprised by the nature, scale, and extent of the failings which you and the inquiry team have so effectively uncovered. In this week of overarching closing statements, you may think that this is the most shocking and most disturbing overarching feature of all. It seems clear now that over many years, the construction industry developed and central government presided over a deeply flawed system. Dame Judith Hackett described the system as not being fit for purpose. You and the panel may consider that judgment to have been, if anything, too generous. You may think that not only was the system deeply flawed, but that corporates working within the system actively sought to take advantage of flaws within it, that there was a culture of gaming the system. I turn now to the 10 key dates which I wish to draw to your attention. 5th of April, 1991, the date of the Knowsley Heights fire in Liverpool. This has been described by both BRE and Professor Bisbee as the most significant of the historic external fires. Professor Bisbee told you that learning the details of this fire was one of two moments in this inquiry which had left him speechless. He referred in particular to discovering that the cladding was glass-reinforced polyester. His point was that because it was a polyester-based product, it was inherently combustible, yet it was regarded as Class 0. So here we have rain-screened cladding, which was supposedly Class 0, but at the same time was combustible and had in fact combusted in a sizable fire. This combination should have been regarded as highly significant. It should have been regarded as worthy of further investigation and analysis. In Professor Bisbee's own words, it was impossible to overstate the importance of what was missed. Knowsley is an early example of a theme repeatedly emphasised by Professor Bisbee. Class 0 was not a suitable measure for assessing the hazard posed by external fire spread in a cladding system. The fact that Knowsley was a pilot scheme backed by central government illustrates another theme. In its quest to promote energy efficiency, central government devoted too little attention to the consequences for fire safety. There was always a possibility that the development of new overcladding technologies would have fire safety implications. This possibility needed to be analysed and kept under review. For any such analysis to be effective, it would need to be evidence-based, and scientists would need to be funded to carry out the necessary research. In Module 7, Professor Torero told you about his decades-long struggle to obtain funding to carry out such research. 19th of September 2002, the date of the report of the CC 1924 tests. This report was prepared for central government by BRE. Several rain screen systems were tested, including an aluminium sheeting system. The report stated that the aluminium sheeting system achieved the poorest classification in both tests, although it was the only system to achieve Class 0. The full-scale test, which was meant to run for 30 minutes, had to be abandoned within under 6 minutes. By then, the flames were 20 metres high. Flames had reached the top of a 10-metre rig even earlier, within 4 minutes and 20 seconds. Everyone who witnessed this test was shocked by the speed with which the fire spread. This was the second of 2 moments in the inquiry that Professor Bisbee said had left him speechless. Specifically, it was the discovery of what had been tested that left Professor Bisbee speechless. The aluminium sheeting system, which failed so catastrophically, was an ACM panel with a PE core, a panel very similar to the one used on Grenfell Tower over a decade later. Like Knowsley 10 years earlier, it is an example of a Class 0 product proving to be combustible and contributing to external fire spread. This test result was not shared to the extent that it could and should have been. It was contained in a document called a client report, which described itself on each page as commercial in confidence. Central government could and should have waived confidentiality and made the report public. It did not do so. The report remained essentially secret until 2021, when a summary of the test was leaked to the BBC. January 14th, 2008. The date of the BBA certificate for Reynobond ACM. A document that with good reason was analysed at great length during the hearings. Today I'm not going to talk about the phrase, the panels may be regarded as having a Class 0 surface. I'm going to use this date to illustrate 2 features of Arconic's conduct. 1, knowingly and deliberately manipulating the UK's weak testing and certification system. 2, withholding safety-critical information. The certificate stated that Reynobond 55 with a PE core was European Class B. It noted that the panels were available in both a riveted system and a cassette system, but drew no distinction between the 2 systems. As Arconic fully appreciated, the certificate therefore represented that its standard PE product was Class B, even when used in a cassette system. Yet by then, Arconic had known for over 2 years that this product was not Class B when used in a cassette system. Arconic knowingly and deliberately manipulated the testing and certification system by ignoring its contractual obligations and not informing the BBA about the safety-critical information from the 2005 test. Arconic spent the next 9 years actively relying on a certificate that it knew to be inaccurate and misleading. The cassette system was retested several times during those 9 years. Not once did it achieve Class B. The best result it ever achieved was Class E. 3rd of July 2009, the date of the Lakanal House fire. At a time of steady reductions in annual deaths caused by fires, Lakanal was a warning that a tower block fire with multiple fatalities could still happen. The risk of one occurring was not just theoretical, it was real, and it could happen in the UK, a point that central government should have kept in mind when in later years serious cladding fires occurred abroad. Many in central government seemed to believe that similar fires could not happen in the UK, but such a belief, however sincerely held, was at best wishful thinking, unless it was supported by empirical evidence and reasoned arguments. 13th of May 2013. the date of an email from Deborah French, Arconic's UK sales manager. The catalyst for the email was a BBC News report about a cladding fire in the United Arab Emirates. It included the following statement: "At this stage, we will continue to offer both PE and FR core and continue the close working relationship we have with our approved fabricators to make sure the right technical support, Rainer Bond specification and materials are being used and installed on Rainer Bond projects." The purpose of the email was clearly to reassure Arconic's approved fabricators concerned by the fire in the UAE, and in turn to enable them to reassure their customers. One of the people to whom the email was sent was Jeff Blades of CEP. It was Mr. Blades who ultimately supplied the ACM panels for Grenfell Tower. The significance of this email is that it establishes, one, that Arconic worked closely with its small network of approved fabricators, and two, that Arconic had an active interest in who used its products and how they were used. In oral evidence, Ms. French agreed that Grenfell Tower was a project where Arconic had close control of the supply chain and worked closely with the fabricator. She also agreed that Arconic was in a position to ensure that the right core ended up on Grenfell Tower. Before she left Arconic at the end of 2014, Ms. French was aware that Grenfell Tower was a high-rise residential building. She was also aware that Rainer Bond PE55 in a cassette system was going to be installed on it. Those involved in the Grenfell Tower project were never informed that the PE core would perform worse in a fire in a cassette system than a riveted system. And they were never even informed that a fire-resistant FR core was an option. In short, the assurances provided by Arconic in the 13th of May email proved to be false. Arconic could and should have made sure that those involved in the Grenfell Tower project had the right technical support. It did not do so. Arconic could and should have made sure that a suitable Arconic product was used and installed at Grenfell Tower. It did not do so. Yet people within Arconic had known since at least 2007 about the potential benefits of using an FR core. In September 2007, one of Arconic's marketing managers suggested in a written report that in future Arconic should consider only selling ACM with an FR core. This followed a meeting he had attended in Oslo, at which someone asked about the responsibility of the ACM supplier if 60 to 70 people died in a fire in a building clad in ACM with a PE core. Subsequently, in June 2015, Claude Verler sent an internal email in which he said in terms, "PE is dangerous on facades and everything should be transferred to FR as a matter of urgency." This wasn't an email from any old employee. Mr. Verler was the head of Arconic's sales technical support team. At least as far as the UK was concerned, nothing happened as a result of these suggestions in the period 2007 to 2017. Arconic took no adequate steps in the decade after the Oslo meeting to promote its ACM panel with an FR core as a better, safer alternative to its ACM panel with a PE core. Instead, it continued throughout this period to characterise the UK as a PE market. 3rd of February 2014. The date on which Mr. Verler emailed colleagues at Arconic a European classification report for Rainer Bond PE55. The report stated that the product was only Class E. It made clear that this classification applied to both riveted systems and cassette systems. The wording of Mr. Verler's covering email left no room for ambiguity. He wrote, the fire achieved classification is E. The previous B-class report done for Rainobond PE in riveted system can no more be used from now. Indeed, this new report cancels all the previous reports. Importantly, one of the colleagues who was sent this email was Ms. French. She confirmed that she would have read it at the time. For Arconic, this was a wholly unwelcome development. The existing BBA certificate was based on the previous Class B report. If that report could no longer be used, the foundations of the BBA certificate were built on sand, and Arconic's strategy for the UK market was under threat. Arconic's reaction to this unwelcome development was to do what it had done in the past, to withhold safety-critical information from people who needed to be told about it. It didn't even share it with the BBA, although it was contractually obliged to do so. Instead, it battened down the hatches and repeatedly ignored requests for information when the BBA was reviewing the certificate in 2014 and 2015. Arconic continued what it had been doing since 2008, actively relying on a certificate which it knew to be inaccurate and misleading. One example of this is the fact that Ms. French sent it to both Harley and CP in April 2014. July 2, 2014, the date of a meeting of the fire group of the Centre for Window and Cladding Technology. Among those who attended were Brian Martin of DCLG and Dr. Sarah Colwell of BRE. Martin specifically referred to this meeting in his final answer at the end of over 7 days of giving evidence. In a section in the minutes on the use of ACM in high-rise buildings, reference was made to the fact that ACM normally had a PE core. It was stated that paragraph 12.7 of approved document B was intended to prohibit the use of ACM with a PE core on high-rise buildings, but that this was not clear from the current wording of 12.7. It was suggested that clarification could be achieved by means of a frequently asked question. The minutes record that Dr. Colwell agreed to raise this with Mr. Martin. Nothing ever came of this. Publishing an FAQ would have been simple, but this never happened. No attempt was made by central government to find out how many high-rise buildings were clad with ACM with a PE core. The minutes of a subsequent meeting, also attended by Dr. Colwell and Mr. Martin, stated, 1, that paragraph 12.7 was poorly written and open to interpretation, and 2, that the title of that paragraph was misleading. At the meeting, it was said that these deficiencies would be changed in the next revision of approved document B. Given that no timetable had been set for when that revision would take place, this was in reality a meaningless statement. It became clear in Module 6 that by this time energy efficiency was a central government priority, but updating approved document B was not. Finding out how many high-rise buildings were clad with ACM with a PE core should by now have been a priority, as should stopping any more being clad with it. Doing so would not have undermined central government's desire to promote energy efficiency. With rain screen cladding, it is the insulation behind the cladding panels that does the work of energy saving. The panels are just there to cover the insulation and protect it from the elements. Banning combustible rain screen cladding panels was both possible and necessary. 11th of August 2014. This date is about the insulation that was installed on Grenfell Tower behind the ACM panels. Insulation that, according to Professor Purser, contributed approximately half of the toxic gases generated by the fire in the cladding. It is the date of a classification report prepared by BRE for Celotex. The report stated that the system described in it had been tested and met the performance criteria set in BR 135. This report represented the culmination of Celotex's ambitions to compete with the market leader, Kingspan, by copying its strategy. The test had been commissioned to assist the launch and marketing of Celotex RS5000. But the test was not a test of RS5000 alone. It was a BS8414 system test, and therefore tested RS5000 together with other products in a complete rain screen cladding system. As BRE's client, Celotex was regarded as the sponsor of the test and had free rein in the selection of all the products in the system. The other products were not chosen because they were representative of a typical rain screen cladding system. Far from it. They were deliberately and cynically chosen for their fire performance in the hope that they would increase the chances of the system passing the test. An earlier attempt to test RS5000 within a cladding system had been unsuccessful. Celotex could have gone back to the drawing board and tried to improve the safety of its product. It chose not to. Instead, Celotex deliberately included products within the tested cladding system, which A, meant that the system was more likely to achieve a pass, but B, were unrepresentative of typical cladding systems used by the construction industry. Celotex must have known that the improved test result could only have been attributable to the presence of the other products, which had been deliberately included for their fire safety performance. Celotex must equally have known that the improved test result proved nothing about the safety of RS5000. This was not scientific research commissioned with the aim of improving product safety. It was a deliberate and cynical attempt to game the system in order to get a test result that would support a sales and marketing strategy. Having got this report, Celotex ceased further testing and focused on marketing RS5000 as acceptable for use in buildings above 18 metres in height. And its sales force focused on targeting individual high-rise projects. Grenfell Tower was one such project. It was described in an email to the UK Managing Director of Celotex's parent company as a must-win project for Celotex. Celotex's sales rep assiduously courted Harley in the hope of winning the contract. He informed Harley in writing that RS5000 was the first PIR board to successfully meet the performance criteria in BR 135 for insulated rain screen cladding systems, and that it was therefore acceptable for use in buildings above 18 metres in height. This was wholly misleading. The test had no validity unless RS5000 was installed in an identical system to that tested by BRE, which for several reasons would never happen. One being that the precise makeup of the system tested by BRE was kept secret and not set out in the relevant testing, certification, and marketing documents. Celotex knew that Grenfell Tower was a high-rise residential building. It knew the attributes and chemical composition of RS5000. It should never have targeted the Grenfell Tower project. September 2014, the date of an exchange of emails between Terry Ashton of Exover and Neil Crawford of Studio E. In the course of these emails, Mr. Crawford sent Mr. Ashton initial drawings which Harley had sent it, and an email from Harley stating that the insulation was Class 0, and the product data sheet for Celotex RS5000. This was, as Dr. Lane has said, a really important moment. The exchange of emails on the 18th of September was an opportunity, but by no means the first opportunity, for Exover to take the following two actions. One, to advise that the insulation to be used in the cladding system needed to be a material of limited combustibility. Two, to reconsider and update the advice in its outlined fire safety strategy. By this date, Exover had produced 3 versions of this document. Each had included the same one-sentence paragraph about external fire spread. It stated, "It is considered that the proposed changes will have no adverse effect on the building in relation to external fire spread, but this will be confirmed by an analysis in a future issue of its report." This paragraph did not adequately address the cladding system. It was also misleading. In his evidence, Mr. Ashton accepted that the paragraph about external fire spread might have given readers of the report a false sense of security. He was right to do so. In short, the statement in that paragraph, in the terms in which it was written, should not have been included in any of the 3 versions of the outlined fire safety strategy. Exover was a top-tier fire safety engineering firm. It knew that a rain screen cladding system was to be installed on Grenfell Tower. The 18th of September 2014 was an ideal opportunity for Exover to give necessary advice that it had not yet given. It was the moment for Mr. Ashton finally to analyse the products proposed for use in the cladding system and advise on the dangers. He didn't do so. Nor did Exover do so at any point thereafter. It never updated the one sentence of advice on external fire spread in its report. 21st of October 2014. This was progress meeting number 4, attended by the TMO, Artelia and Ryden. It included as an action point that Simon Lawrence of Ryden was to appoint a fire consultant. This action point had also been included in the minutes of progress meetings 1, 2 and 3. Ryden never did appoint a fire consultant, and after this meeting, this action point disappeared from the minutes of the progress meetings, never to return. Mr. Lawrence's evidence was that in his experience, Ryden never engaged fire consultants. Stephen Blake, Ryden's refurbishment director, told the inquiry that on a project of this size, it was normal for Ryden not to appoint one. Not appointing Exover or another fire consultant was therefore a positive decision by Ryden, rather than an action point that slipped through the cracks. Mr. Blake confirmed this when he gave evidence. As at October 2014, Ryden should have been aware that Exover had provided minimal advice on the cladding system. Ryden itself had no in-house fire safety expertise. Therefore, Ryden's decision not to appoint a fire consultant meant that no fire engineer ever properly considered the safety of a cladding system. Mr. Lawrence was surely right to say that, in hindsight, a fire consultant was definitely essential. In short, Ryden, as design and build contractor, needed advice from a fire engineer. There were multiple opportunities for Ryden to obtain the necessary advice, opportunities which could and should have been taken, but were not. That concludes the list of dates which I wish to draw to your attention today, although, as I said earlier, there are many others that I could have chosen. The 10 dates which I have identified and the wider themes which they illustrate support my central theme. But it should never have been the case that a single local authority building control service was all that stood between dangerous products being used on Grenfell Tower. My final date took us up to October 2014. At that time, the installation of the Rainabond PE55 and the RS 5000 had not begun. That remained the case for another 6 months. The panel will recall that in an earlier stage of this inquiry, some people seemed to be suggesting that the Council's Building Control Service was part of the design team for the project. In the course of the inquiry, the factual evidence, the expert evidence, and the relevant case law all combined to make it very clear that building control services have no role in design and are not part of design teams. Mr. Taverner, King's Counsel, on behalf of Ryden, accepted at the end of modules 1 and 2 that the Council's Building Control Service was not part of a design team. The TMO and Ryden, between them, assembled a large and apparently reputable team of paid advisors and contractors. Dr. Lane's evidence on the composition of the team was as follows. It would be entirely reasonable for KC TMO, and indeed any party, to assume that the project team had access to and could rely on highly competent experts for all aspects of fire safety design and compliance. Nevertheless, this team designed and installed a dangerous cladding system. I end this first part of this statement where I began. There were failings in how the Council's Building Control Service dealt with the application for building control approval. Building Control issued a completion certificate on the 7th of July 2016. It should not have done so. I now turn to the second part of this statement, to the fire safety measures within Grenfell Tower. This inquiry is rightly interested in the condition of the inside of the tower as well as the exterior, and a substantial part of Module 3 was devoted to the nature, design, maintenance and performance of the active and passive fire safety measures within the tower. When thinking about the inside of a tower, it is worth reminding ourselves of how it was managed. The Council was the owner and landlord of Grenfell Tower. The tower was managed for it by the TMO. The Council scrutinised and monitored the TMO. The Council has previously admitted a number of failings in its monitoring of the TMO. I reminded the panel of some of them at the start of this statement. I'm not going to repeat them again at this point, but the Council stands by its admissions and apologises unreservedly for its failings. In the first part of this statement, I sought to focus on the national dimension and on overarching points. I will be taking the same approach in this part. It is for this reason that I will be focusing on the role of fire risk assessors generally and the role of the fire risk assessor for Grenfell Tower. Following the Lakanal House fire, it became increasingly common for responsible persons to engage external fire risk assessors to carry out fire risk assessments. Central government was aware of this phenomenon, yet it never introduced a competency requirement for fire risk assessors. When giving evidence in Module 3, Colin Todd told the inquiry that the absence of a competency requirement for fire risk assessors was not an oversight. He said that it was intentional government policy. He also said that central government very positively resisted all calls for competence to be made mandatory. The evidence in Module 6 confirmed this. In the years before the Grenfell Tower fire, there were a large number of missed opportunities to impose mandatory competence requirements on fire risk assessors. We listed 9 of the most notable ones in our Module 6 closing statement. Between 2010 and 2017, Carl Stokes was in effect the sole provider of fire risk assessments to the TMO. This provided him with an opportunity to assess the TMO's fire safety management system and to advise the TMO on it. But his involvement was not limited to the preparation of fire risk assessments. He was frequently asked to advise, and did advise, the TMO on a wide range of fire safety related issues. As a result, Mr. Stokes learned a lot of important information between fire risk assessments, which was relevant to the next occasion when he carried out a fire risk assessment. As the TMO's fire risk assessor and go-to person for advice on fire safety measures, Mr. Stokes was the most experienced and qualified person involved in the delivery of the TMO's fire safety management system. Dr. Lane recognised the importance of Mr. Stokes. On more than one occasion in her expert report, she stated, "Between Ms. Ray and Mr. Stokes, in my opinion, KCTMO should have had access to adequate advice." Given the importance of Mr. Stokes to Grenfell Tower, we devoted part of our written closing statement to analysing the evidence relating to his initial appointment by the TMO and concerns subsequently expressed about his competence by the LFB. I'm not going to repeat what we have said in writing, other than to remind you of one point, which is this. The concerns raised by the LFB with officers of the TMO were not communicated to either the TMO board or the council. I turn now to the issue of flat entrance doors, one of many issues which Mr. Stokes advised on. He also considered them on each occasion when he carried out a fire risk assessment of Grenfell Tower. At the time of the fire, there were 120 flats in the tower located on floors 4 to 23. The flat entrance doors to 106 of those flats had been replaced in the period 2011 to 2013. All of the 106 new flat entrance doors were fitted with self-closers at the time of installation. In the years that followed, no programme of inspecting those doors to see if the self-closers remained present and functional was ever introduced. It is now clear that a significant number of flats within Grenfell Tower did not have functioning self-closers on the night of the fire. The council has previously admitted that it was wrong to tell the TMO, 1, that the programme to install self-closers should be a 5-year programme rather than a 3-year programme, and 2, that there should not be an inspection programme. The council does not seek to qualify its submissions, but it does seek to ensure that they are seen in their proper context. Part of that context concerns the discussions that took place between the TMO and the council. I have previously made 6 separate points about those discussions. For today's purposes, I can boil those 6 points down to 2. The TMO failed to make the best case for an inspection programme and a 3-year installation programme. As a result, Laura Johnson's response to the TMO was based on imperfect information. A second part of that context is the difference between what the TMO knew and what the council knew about what was happening on the ground in relation to self-closers. Dr. Lane identified 3 reoccurring faults that arose with the doors installed in the flat entrance door replacement programme. During the Module 3 hearings, there was a good deal of evidence about who within the TMO knew what about these matters, but there was no suggestion that the council was aware of them, and there was no evidence that anyone from the council was made aware of them. During Phase 1, the inquiry heard evidence that a handyman employed by the TMO had disconnected a number of self-closers within Grenfell Tower. There has been no suggestion or evidence that anyone from the council knew about the handyman's actions. A third part of the context is the advice sought from and given by Mr. Stokes to the TMO on this issue. One matter which the inquiry's experts agreed on was this. It was part of Mr. Stokes' role to monitor and assess the adequacy of the system of maintenance and inspection of the self-closers. Yet Mr. Stokes failed to advise the TMO of the need for a programme of an inspection and maintenance, although there were clear opportunities for him to do so. I will give one example of this, although many others could be given. In January 2013, the TMO sent Mr. Stokes a draft of the TMO's fire safety strategy and expressly asked him, "What else should I include?" Counsel to the inquiry asked Mr. Stokes, "Why did you not add the need for a policy which would cover a planned maintenance programme for flat entrance doors with an inspection every 6 months, as by now set out in the LGA guide?" Mr. Stokes replied, "I can't answer that question." Counsel persisted and asked, "Well, is it because you have no answer?" To which Mr. Stokes replied, "Well, yes." I return now to a point I made when I started this topic about the fire safety measures within Grenfell Tower. The fact that central government never introduced a competency requirement for fire risk assessors. Anyone can call themselves a fire risk assessor. It is not a legally protected title, and it is not alone in that. The same is true of engineer, fire engineer, and fire safety engineer. Architect is a legally protected title, but an architect's practice can employ someone without that formal qualification to do work for it, as Studio E did with Neil Crawford. This approach to competence in the field of fire safety should be a major concern, given the evidence of Professors Bisbee and Torero about the central importance of competence in a system based on functional requirements, and about the low levels of competence they had experienced. The missed opportunities to introduce a competency requirement for fire risk assessors had potential consequences. If central government had made fire risk assessment a profession, it could have had a number of benefits, in addition to requiring all fire risk assessors to hold minimum standardised qualifications. We have analysed those benefits in more detail in our written statement, but I will mention some of the key ones now. Introducing a mandatory competence requirement could have raised standards within the fire risk assessment industry. It could also have raised the status of fire risk assessors, and it could have provided third parties with an authoritative benchmark against which to assess fire risk assessors. The availability of an authoritative benchmark could have been a useful aide-memoire and could have provided Mr. Stokes with greater clarity on what was expected of him as a fire risk assessor. In addition, raising the status of fire risk assessors by making them professionals would have been a decisive break with the mindset that fire risk assessments would be done quickly, cheaply, and in-house. Professional fire risk assessors would have been able to justify charging more and to justify taking the time required to do the job to the appropriate standard. An organisation such as the TMO would have had to find the extra money required to pay for the services of a member of a profession. If a TMO needed to apply to the council for the extra money, clear mandatory legal requirements would have provided it with arguments that it could use to make a case to the council for additional funds. That brings me to the end of the second part of this statement. Finally, some concluding remarks, if time permits, before the break.
Yes, it would be convenient, wouldn't it, for you to continue for a moment?
It would very much so.
Yes, of course then. Thank you.
This week of final closing statements is an important milestone in the inquiry. On Monday morning, you heard powerful and passionate submissions about the need for robust recommendations to address deep-rooted systemic problems. The leader of the council, who is here today, has asked me to make it clear that as far as she and the council are concerned, these closing statements do not mark the end of the road. At the beginning of phase 1, we said that the ultimate achievement of this inquiry would be to ensure that when people design, construct and refurbish buildings in future, a disaster like this never happens again. The Council remains determined to do what it can to achieve this. Since the fire, the Council has completely changed the way housing is managed in the borough. The Council now has direct responsibility for the management of its social housing properties. It is directly accountable to its residents for its management of those properties. The Council has made significant changes in many areas, including its building control service, resident engagement, and how it manages fire safety. During the course of this inquiry, the Council has on a number of occasions provided the inquiry with documents detailing changes it has made. The most recent such document, submitted at the end of last month, did not only address what has been done, it also details some of the Council's ongoing work and plans for the future. The Council believes that at the national level, progress has been too modest and too slow. It also believes that too much of the national fire safety and building safety system is too broken to be fixed by minor changes. In our submission, the starting point for the panel should be to recognise that fundamental change is needed, that there are vested interests opposed to change which will need to be overcome, and that in order to achieve the necessary fundamental change, there will need to be both legislative change and cultural change. The residents of Grenfell Tower were failed by many, many organisations, from both the private sector and the public sector. The Council was one of them. But the Council is conscious that it differed from most of the other core participants in important respects. It was not an anonymous cladding subcontractor or manufacturer whom the residents might never have heard of. It was the owner of Grenfell Tower. The residents were its tenants and its leaseholders. The Council was democratically accountable to them. The Council apologises unreservedly for the ways in which it failed the residents of Grenfell Tower. It wishes to say how sorry it is to each of the bereaved, everyone who survived, and all of its residents.
Thank you very much, Mr. Maxwell-Scott. Well, we'll rise at that point and we'll resume at 2:05 when we shall hear a closing statement from Mr. James Ageros, King's Counsel, on behalf of the Tenant Management Organisation. Thank you very much. 2:05, please.